You just spent $50, maybe $55 with tax. You walked into your local hardware store, you told the guy behind the counter that your basement wall is damp, that water is creeping through your foundation every time it rains, and he pointed you to aisle 9. And on aisle 9, sitting under fluorescent lights like it was some kind of miracle in a bucket, was a 5-gallon pail of something called Advanced Masonry Waterproofing Sealer. Maybe it had a different brand name at your store. Maybe it said Penetrating Concrete Shield. Maybe it said Professional Grade Crystalline Barrier. The name changes depending on which corporation printed the label, but the game is always the same. You picked it up, you read the back, and it said something about advanced silicate technology and permanent moisture protection and laboratory-tested formulation. And you thought, okay, this must be serious science, this must be worth the money. You brought it home, you painted it on your wall with a brush, and you felt like you just did something smart. You felt like you just protected your home. And here is where I need you to sit down, because what I'm about to tell you is going to make you sick to your stomach. That $50 bucket of so-called advanced masonry sealer is, in the vast majority of these products, mostly water. The active ingredient, the thing actually doing the work, the molecule that is actually penetrating your concrete and forming a waterproof crystal inside the pore structure of your wall, is a chemical called sodium silicate. You might know it by its old name, liquid glass. And you can buy it yourself in raw technical grade powder form for about $3 a pound. $3. Not 30, not 50, 3. And a single pound of that powder, mixed with plain tap water at the correct ratio, will produce enough working waterproofing solution to seal an entire basement wall. I am going to say that again because the math needs to hit you. The raw chemistry that does the actual waterproofing costs you $3. The branded bucket with the fancy label and the word advanced in bold letters costs you $50. That is not a small markup. That is not a reasonable business margin. That is a 1,500% price increase for the privilege of not knowing what is inside the bucket. And the home repair industry, the concrete sealer industry, the billion-dollar waterproofing sector, they are counting on one thing and one thing only. They are counting on the fact that you do not know basic chemistry. They are counting on the fact that the words sodium silicate mean nothing to you. They are counting on the fact that you will see a proprietary trade name on a glossy label and assume it must be some kind of advanced synthetic technology that could only be produced in a specialized laboratory. And I am here to tell you, in the year 2026, while inflation is eating your paycheck alive and a simple foundation repair quote is coming back at $8,000, that this is one of the oldest chemical tricks in human history. This is not a new invention. This is not some cutting-edge nanotechnology. Sodium silicate was first documented in the early 1800s. It has been used to waterproof concrete, to fireproof wood, to preserve eggs, to harden stone for over 2 centuries. The only thing that changed is that someone figured out how to put it in a bucket, call it something else, and charge you 15 times what it is worth. Now let me be absolutely clear about something before we go any deeper. The industries making billions of dollars off your leaking basement want you to think this is dangerous. They want you to think that mixing a basic mineral salt with water is some kind of hazardous chemical operation that requires a laboratory and a degree. It is not. Sodium silicate is classified as generally recognized as safe. It is used in food preservation. It is used in water treatment. It is a basic alkaline silicate salt. But as always, everything I share on this channel is for educational purposes. I am showing you the historical chemistry, the documented science, the exposed markup. What you decide to do in your own garage with $3 of raw mineral powder and a bucket of water, that is your decision. This is for bare masonry waterproofing on porous concrete and brick. This is not a substitute for repairing severe structural cracks. If your foundation has significant structural damage, you need an engineer. What I am exposing is the financial scam of paying $50 for a diluted version of a $3 chemical on surfaces where the raw chemistry does the exact same job. And if that distinction makes the waterproofing industry uncomfortable, good. They should be uncomfortable. Because what they have been doing to homeowners for decades is highway robbery dressed up in laboratory language. Let me know in the comments below. Have you ever paid premium prices for a branded waterproofing bucket only to find out it was a basic chemical mix? Have you ever stood in that aisle, read the back of one of those buckets, and felt like you were buying something proprietary, something exclusive, something that justified that price tag? I read every single comment on this channel. Everyone. And the stories I get from people who realize they have been overpaying for commodity chemicals repackaged under trade names, those stories are heartbreaking. Because it is not just $50, it is the principle. It is the realization that an entire industry has been profiting off your lack of chemical vocabulary. So tell me your number. Tell me what you paid. Because I guarantee you, by the end of this video, you are going to see that receipt very differently. Now here is where this gets really powerful. And this is the part the industry absolutely does not want you to know. Sodium silicate is not some modern chemical that was invented in a corporate lab in the 1990s and patented. This chemistry is ancient, and I do not mean old, I mean centuries old. Exposed, documented, field-tested under the most brutal conditions human civilization has ever faced. And the fact that they have managed to rebrand it as some kind of exclusive proprietary technology in the 21st century is one of the most impressive marketing frauds I have ever encountered. Let me take you back to the 1800s. The British Royal Navy in the mid-19th century had a massive problem. Their warships were made of wood, oak, teak, massive timbers that took decades to grow and years to shape into a hull, and those ships were constantly at risk of fire. Naval warfare in that era meant cannon fire, burning pitch, incendiary attacks. One well-placed shot and your entire ship could go up in flames, and the loss was not just the vessel. It was the crew, the cargo, the years of construction, the strategic position. The Admiralty needed a way to make wood resist fire, and what did they turn to? Sodium silicate, liquid glass. They discovered that if you dissolved sodium silicate in water and applied it to timber, it would penetrate the wood fibers, and as the water evaporated, it would leave behind a thin, glassy mineral film inside and on the surface of the wood. That film was not organic, it could not burn. It was essentially a microscopic layer of glass fused into the cellular structure of the wood, and it worked. Royal Navy dockyards were documented using sodium silicate treatments on ship timbers, on rope, on canvas sails to reduce flammability. This was not a secret. This was published. This was in engineering journals and admiralty records. The British Empire, at the height of its naval power, was using a chemical you can buy for $3 a pound to protect its most valuable military assets. Think about that. The most powerful navy on Earth in the 1800s trusted this exact molecule with the survival of its fleet. And today, in 2026, a hardware store is telling you that you need to pay $50 for a proprietary version of the same thing to keep water out of your garage wall. Now let me jump forward to the early 1900s. World War I, the Western Front, trench warfare. If you have ever seen photographs of those trenches, you know the conditions were absolutely inhuman. Constant rain, constant shelling, mud everywhere, the trenches filled with water, the bunkers flooded. The concrete fortifications that were supposed to protect soldiers from artillery were being undermined by moisture penetration. Water was getting into the concrete, freezing and expanding in winter, cracking the structures, weakening defensive positions. Military engineers on both sides needed a way to waterproof concrete quickly, cheaply, and with materials they could actually get to the front lines. They did not have the luxury of waiting for some proprietary product to be shipped from a factory. They needed something they could mix in the field with basic supplies. And once again, the answer was sodium silicate. Military engineering manuals from World War I document the use of sodium silicate solutions applied to concrete surfaces to seal them against water penetration. The chemistry was already well understood by that point. You dissolve the sodium silicate, you brush it or spray it onto the concrete, it soaks into the pores, and it reacts with the calcium compounds inside the concrete to form an insoluble crystalline structure. That crystalline structure is what blocks the water. It fills the capillary pores of the concrete from the inside. It does not sit on top like a paint. It becomes part of the concrete itself. And this was being done in muddy trenches, under artillery fire, by soldiers with no chemistry degrees, using basic supply chain materials. The idea that you need a $50 bucket with a holographic label and a customer service hotline to accomplish the same thing on your dry, stable, peacetime basement wall is absolutely laughable. And let me give you a third example because this pattern needs to be undeniable. After World War II, in the massive rebuilding effort across Europe, sodium silicate saw another enormous surge in use. Cities had been bombed, infrastructure was destroyed, millions of buildings needed to be repaired or rebuilt quickly and cheaply. Concrete was the primary building material of reconstruction, but concrete is inherently porous. Fresh concrete especially is full of capillary channels and microscopic voids. And in a climate like Northern Europe, with constant rain and freeze-thaw cycles, untreated concrete deteriorates rapidly. Water gets in, it freezes, it expands, it cracks the concrete from the inside. Spalling, scaling, the whole surface starts to disintegrate within a few years. Post-war engineers knew this. And they knew the solution was the same solution the Navy had used a century earlier, the same solution the trench engineers had used 30 years earlier, sodium silicate. They applied it to freshly poured concrete foundations, to bridge piers, to tunnel linings, to water treatment facilities. It was cheap, it was effective, and it was universally available because it was a basic industrial commodity chemical, not a patented luxury product. The reconstruction of Europe literally relied on this $3 mineral salt to protect its new infrastructure from water damage, bridges that are still standing today, water treatment plants that are still operating, foundations that have survived 80 years of Northern European winters. All sealed with the same molecule that is sitting in that $50 bucket at your hardware store right now, diluted down and dressed up with a marketing budget. 3 eras, 3 completely different contexts. The wooden warships of the British Empire, the concrete bunkers of World War I, the rebuilt cities of post-war Europe. And in every single case, the answer was the same cheap, abundant mineral chemistry. Sodium silicate, liquid glass. The convergent chemistry here is undeniable. When the most demanding engineering challenges in human history needed waterproofing and fireproofing, they did not reach for a proprietary brand. They reached for a basic commodity salt, and it worked. Every single time. If you are tired of paying a 1,500% markup for basic minerals wrapped in clever marketing, hit the like button right now. I am not asking for my ego. Every single like forces the algorithm to push this factual chemistry past the corporate filters and into the feeds of homeowners who are right now standing in that hardware store aisle about to hand over $50 for $3 worth of mineral powder dissolved in water. Your like is not a vanity metric. It is an act of consumer resistance. Hit it. Now let me explain exactly why the industry can get away with this. Because this is not an accident. This is not a case of companies innocently adding value through convenience. This is a mathematically engineered business model, and it has a name. Planned obsolescence meets proprietary repackaging. And in 2026, in the middle of the worst inflation crisis most of us have ever lived through, understanding this model is not optional, it is survival. Here is how it works. Step 1. You take a commodity chemical. Sodium silicate is produced industrially on a massive scale. It is made by fusing silica sand with sodium carbonate, which is soda ash, another incredibly cheap and abundant mineral. The raw material inputs are literally sand and soda ash. The production process is straightforward high-temperature fusion. There is nothing exotic about it. The global supply is enormous because sodium silicate is used in dozens of industries, from paper manufacturing to water treatment to detergent production. It is one of the most commonly produced industrial chemicals on the planet. The bulk wholesale price for technical-grade sodium silicate is pennies per pound in large quantities. Even at retail, a consumer buying a small amount is looking at roughly $3 to $5 per pound. Step 2. You dilute it. You take that cheap powder, you dissolve it in water at a specific ratio, and now you have a liquid product. The water costs you essentially nothing. The container, the bucket, the jug, that costs you maybe $1 or $2 in bulk manufacturing. The label, the printing, the graphic design, maybe another 50 cents per unit at scale. Your total cost of goods for a gallon of working sodium silicate solution is somewhere in the range of $2 to $4, and that is being generous with the overhead. Step 3. You give it a name. Not sodium silicate. Nobody would pay $50 for something called sodium silicate solution. You call it something like Crystal Shield Pro or Deep Seal Advanced Masonry Technology or Hydro Barrier Penetrating Concrete Sealer. You invent a brand, you design a label with technical-looking graphics. You write marketing copy that uses words like laboratory engineered and proprietary crystalline matrix and advanced molecular bonding. None of these phrases are technically false in a way that would trigger regulatory action, but they are designed to make you believe you are buying something that could not possibly be a basic mineral salt dissolved in water. Step 4. You price it at $50 a gallon or more, because you have now created a perception gap. The customer does not know what sodium silicate is. The customer does not know that the active ingredient in their $50 bucket is the same chemical that is available for $3 a pound in raw form. The customer sees the brand name, the professional label, the technical language, and they assume this must be a complex, expensive formula. That assumption is worth $45 of pure profit margin per bucket, and that margin is not paying for research and development. There is nothing to develop. This chemistry was understood 200 years ago. That margin is not paying for exotic raw materials. The raw materials are sand and soda ash. That margin is paying for one thing: your ignorance, your lack of chemical literacy, your inability to read an ingredient list and recognize a commodity mineral salt when it has been dressed up in corporate language. And this is the model that runs across the entire home repair industry. It is not just waterproofing sealers, it is rust converters that are just diluted phosphoric acid. It is wood hardeners that are just diluted consolidating resins. It is concrete densifiers that are just, you guessed it, diluted sodium silicate or lithium silicate. It is driveway sealers, it is garage floor coatings, it is brick waterproofing sprays. The playbook is identical every single time. Take a commodity chemical that has been in use for decades or centuries, dilute it, rebrand it, and sell it at 10 to 20 times the raw material cost. And they get away with it because the average homeowner does not have a chemistry background. The average homeowner trusts the brand. The average homeowner assumes that a higher price means a better product. And in most cases, the higher price just means a higher water content and a fancier label. Let me do the math for you, because I want this to be painfully concrete. A typical commercial masonry sealer that is silicate based will retail for somewhere between $40 and $60 per gallon. Let us call it 50. Now, a working sodium silicate waterproofing solution for concrete penetration is typically mixed at a ratio of about 1 part sodium silicate to about 3 to 5 parts water, depending on the concentration of your starting material and the porosity of the substrate. If you are buying sodium silicate powder, which is the most concentrated and cost-effective form, you need even less by weight because the powder is essentially 100% active ingredient with no water weight. A pound of sodium silicate powder, costing you about $3 to $5 retail, will make roughly 1 gallon to 1.5 gallons of working solution when dissolved in water. So your cost per gallon of working solution, made from raw powder, is approximately $3 to $5. The commercial bucket costs $50. That is a markup of 1,000 to 1,500% on the active chemistry. And the commercial version almost certainly has a lower concentration of active sodium silicate per gallon because they have diluted it more heavily with water, so you are paying more and getting less active ingredient. The math is not ambiguous. The math is obscene. And here is the thing that really gets me. It is 2026. We are in an era where people cannot afford to fix their homes. The average foundation repair estimate right now is between $5,000 and $15,000. Basement waterproofing contractors are quoting homeowners $3,000 to $8,000 for interior drainage systems. People are taking out home equity lines of credit to fix wet basements. And a significant portion of those moisture problems, not all of them, but a significant portion, could be addressed or dramatically improved by a simple sodium silicate treatment on the interior concrete walls. A treatment that costs $3 to $5 in raw materials, a treatment that any homeowner can apply with a garden sprayer and a weekend afternoon. But they do not know. They do not know because the industry has spent decades making sure they do not know. They do not know because chemical literacy is not taught in schools. They do not know because the marketing machine of the waterproofing industry is designed to make sodium silicate sound like a dangerous industrial chemical that only trained professionals should handle, when in reality, it is less hazardous than the bleach under your kitchen sink. Now, let me get into the actual science, because I do not want you to just take my word for this. I want you to understand exactly what is happening at a molecular level when sodium silicate meets concrete. Once you understand this, no marketing copy on any bucket will ever fool you again. This is the part the industry definitely does not want you to know, because once you understand the mechanism, the $50 price tag becomes indefensible. Concrete is not a solid, impermeable material. I know it looks solid, I know it feels solid when you knock on it, but at a microscopic level, concrete is riddled with tiny channels called capillary pores. These are microscopic pathways that formed during the original curing process when excess water evaporated out of the concrete mix. Think of them like millions of tiny straws running through the thickness of your wall. When water hits the outside of your concrete wall, it gets pulled into these capillary pores by capillary action, the same physics that makes water climb up a thin paper towel. That is why your basement gets damp. It is not necessarily that water is flooding through a crack. It is that water is being sucked through millions of microscopic channels by basic physics. The concrete is drinking the water. Now, inside that concrete, there is a compound called calcium hydroxide. It is a natural byproduct of the cement hydration process. When Portland cement mixes with water during the original concrete pour, one of the reaction products is calcium hydroxide. It just sits there in the pore structure, doing nothing useful, actually making the concrete slightly weaker and more permeable because it is water soluble. It can leach out over time, leaving even more open pore space behind. This is the free calcium that we are going to use. When you apply a sodium silicate solution to the surface of that concrete, the silicate molecules are very small, small enough to penetrate into those capillary pores along with the water they are dissolved in. The solution soaks into the concrete, sometimes penetrating several millimeters deep depending on the porosity and the concentration. And once inside, the sodium silicate meets the calcium hydroxide. And this is where the magic happens. A chemical reaction occurs. The sodium silicate reacts with the calcium hydroxide to form a new compound called calcium silicate hydrate. Now, calcium silicate hydrate is a very specific material. It is the same compound that gives concrete its actual structural strength. When cement hydrates, the primary binder that holds everything together is calcium silicate hydrate, often abbreviated as CSH by concrete chemists. It is a dense, insoluble crystalline gel that fills space and bonds aggregate particles together. So when you introduce sodium silicate into the pore structure of existing concrete, and it reacts with the free calcium hydroxide to form additional calcium silicate hydrate, you are essentially growing new concrete binder inside the empty pore spaces of your old concrete. The pores get filled, the capillary channels get blocked, the The crystal growth is permanent because calcium silicate hydrate is insoluble in water. It does not wash away. It does not break down. It becomes a permanent part of the concrete matrix. You have essentially turned porous, leaky concrete into denser, less permeable concrete by triggering a secondary hydration reaction using a $3 mineral salt. And this is also what the industry calls a pozzolanic reaction, or more precisely, a pozzolanic adjacent silicate densification. In traditional concrete science, a pozzolanic reaction is when a siliceous material reacts with calcium hydroxide in the presence of water to form cementitious compounds. Fly ash does this, silica fume does this, and dissolved sodium silicate does this when it contacts the calcium hydroxide in your existing concrete. The reaction is well documented in concrete science literature. It is taught in civil engineering programs. It is the basis of a whole category of commercial products called silicate densifiers and concrete hardeners that are used on industrial floors, in parking garages, in warehouse facilities. The professionals know exactly what this chemistry is. They use it every day. The only people being kept in the dark are residential homeowners who are sold the same chemistry under a different name at a completely different price. This is not some exotic, unstable reaction. This is one of the most well-understood processes in materials science. The formation of calcium silicate hydrate from the reaction of silicate ions with calcium ions in an alkaline aqueous environment has been studied for over 100 years. The crystal structure is well characterized, the reaction kinetics are well documented. The long-term durability of CSH in concrete is proven by literally every concrete structure that has ever stood for more than a few years, because CSH is what holds all of them together. When you apply sodium silicate to your basement wall, you are not painting on a temporary coating. You are triggering a permanent mineralogical transformation inside the pore structure of the concrete. And the total cost of the chemical input for that transformation is about $3. There is another aspect to this that most people miss, and it has to do with why the treatment actually gets stronger over time rather than weaker. Unlike a surface coating or a paint, which sits on top and can peel, crack, chip, or degrade under UV or moisture cycling, the calcium silicate hydrate that forms inside the concrete pores is protected from the environment. It is inside the concrete. It is not exposed to sunlight, to abrasion, to surface wear. And because it is insoluble, it is not affected by additional water exposure. In fact, any subsequent moisture that enters the pores can potentially carry unreacted sodium silicate deeper into the concrete, where it can encounter more free calcium hydroxide and form even more CSH. The treatment can actually continue to improve the concrete's density over multiple application cycles. This is why historical structures treated with sodium silicate have lasted for decades, and in some cases over a century. The chemistry does not degrade, it mineralizes. It becomes part of the stone. Now here's how you actually do this yourself. And I want to be clear. This is straightforward, this is not complicated. If you can mix a pitcher of lemonade, you can mix a sodium silicate waterproofing solution. The industry has every incentive to make you think this is difficult. It is not. Step 1. You need to acquire technical-grade sodium silicate. You can find this in powder form or in a pre-dissolved liquid concentrate. The powder form is the most cost-effective because you are not paying to ship water weight and you can control your own dilution ratio. Technical-grade sodium silicate powder is available from chemical supply companies online. You are not buying anything exotic or restricted. This is a commodity industrial chemical. A 1-pound bag or a 2-pound bag will typically cost you between $3 and $8 depending on the supplier and the quantity. That is enough raw material to treat a significant area of concrete wall. Step 2. You mix it with water. For concrete waterproofing, a typical working concentration is somewhere around a 1:3 or 1:4 ratio by weight, meaning 1 part sodium silicate powder to 3 or 4 parts water. If you are using a pre-dissolved liquid concentrate, which often comes at around 30 to 40% solids concentration, you may dilute it further, typically 1 part concentrate to 2 or 3 parts water, to get a workable solution that is thin enough to penetrate the concrete pores effectively. You want the solution to be watery, not thick. The goal is penetration, not surface coating. If it is too thick, it will just dry on the surface and not soak in. You mix this in a clean plastic bucket. You stir it until the powder is fully dissolved. That is it. That is the formulation. The same formulation that the $50 bucket contains, minus $45 worth of marketing and profit margin. Step 3, you prepare the concrete surface. And this is actually important. The concrete needs to be bare. No paint, no previous sealers, no coatings. The sodium silicate needs direct access to the pore structure of the concrete to penetrate and react. If there is paint on the wall, the silicate cannot get through. You may need to strip any existing coatings first. The concrete should also be clean, free of dust, dirt, efflorescence, or any surface contamination that could block penetration. A simple wash with water and a stiff brush is usually sufficient. Let the surface dry until it is damp, but not wet, not dripping. You want the pores to be open and receptive, not already saturated with plain water. Step 4. You apply the solution. You can use a garden pump sprayer, a paint roller, or even a large brush. Spray or roll the solution onto the concrete wall generously. You want to wet the surface thoroughly so that the solution has time to soak in before it dries. On a porous concrete block wall, you will actually see the solution being absorbed into the surface. That is exactly what you want. It is going in, it is entering the capillary pores. If the surface seems to absorb the first coat quickly, wait 30 to 60 minutes and apply a second coat. Some highly porous concrete can benefit from 3 coats applied over several hours. Each coat pushes more silicate deeper into the pore structure and reacts with more calcium hydroxide to form more calcium silicate hydrate. Step 5. You let it cure. After the final application, the solution needs time to react and crystallize inside the concrete. This typically takes 24 to 72 hours for the initial reaction to complete, though the densification process continues slowly for days and even weeks afterward. During this time, the concrete surface may develop a slight white haze as excess sodium salts migrate to the surface. This is normal and can be rinsed off with water once the treatment has cured. The active waterproofing barrier is inside the concrete, not on the surface. And that is it. That is the entire process. Raw mineral salt, water, a bucket, a sprayer, and a weekend afternoon. Total material cost for an average basement wall, depending on the size, somewhere between $5 and $15. Compared to the hundreds of dollars in commercial branded sealers or the thousands of dollars a waterproofing contractor would charge to do essentially the same thing with essentially the same chemistry. Now, I need to add something here because I am a responsible educator and I actually care about the people watching this channel. Sodium silicate waterproofing is excellent for what it does. It densifies and seals the pore structure of concrete and masonry. It dramatically reduces moisture transmission through capillary action. It is proven, it is permanent, and it is incredibly cost-effective. But it is not a magic bullet for every moisture problem. If your basement has active water intrusion through structural cracks, if there is hydrostatic pressure from a high water table pushing water through the foundation, if there are gaps around pipe penetrations or where the wall meets the footing, sodium silicate alone is not going to solve those problems. Those are structural and drainage issues that may require physical repairs, crack injection, interior or exterior drainage systems, or sump pump installation. Do not let anyone tell you, including me, that a $3 chemical will fix a $20,000 structural problem. What I am telling you is that for the very common issue of general dampness and moisture wicking through porous concrete block or poured concrete walls, the same active chemistry in the $50 bucket is available to you for $3. And for that specific application, the do-it-yourself approach using raw sodium silicate is chemically identical to what the branded product does. Look at your own garage or energy bill right now and tell me in the comments how much you have spent fixing moisture problems in your home. Tell me what that contractor quoted you. Tell me what you paid for those buckets of sealer. I read every single one of these comments, and the numbers I see are sickening. People spending $200, $500, $1,000 on branded silicate sealers when the entire chemical payload in those products costs less than a fast food meal. In 2026, when every dollar counts, when groceries alone are breaking family budgets, the idea that the construction materials industry is charging a 1,500% markup on sand and soda ash dissolved in water is not just frustrating. It is predatory, it is exploitation of chemical illiteracy, and it needs to be called out. This is what I mean when I talk about convergent chemistry on this channel. This is what I mean when I say that the most effective solutions in human history keep converging on the same cheap, abundant, natural materials. The British Navy knew. The World War I engineers knew. The post-war reconstruction crews knew. Concrete scientists have always known. Industrial floor contractors know right now. The only people who do not know are residential homeowners, because the residential market is where the markup lives. The industrial buyer knows exactly what sodium silicate is and pays commodity prices for it. The residential buyer sees a branded bucket and pays 15 times more for the same molecule. That information asymmetry is not accidental. It is the business model. Chemical literacy is the single most powerful money-saving tool you will ever develop. Not coupons, not sales, not bulk buying. Understanding what is actually inside the products you are buying, knowing the real name of the active ingredient, knowing its commodity price, and knowing that you can source it yourself. That knowledge collapses the entire markup structure of the home repair industry. Every single video on this channel is a brick in that foundation. Every chemical we expose, every proprietary trade name we strip back to its commodity roots, every markup we calculate in real time is another tool in your belt. Subscribe right now and hit the bell. I am not saying this to grow a number. I am saying this because we are building something here. We are building an archive of forgotten, unbranded, historically proven knowledge that the industries counting on your ignorance do not want you to have. Every subscriber makes this archive harder to bury. Every bell notification means you see the next chemical exposure before the algorithm decides to suppress it. We are not a channel. We are a library, and this library is free. Unlike that $50 bucket of water and sand you just bought at the hardware store. Get in here, subscribe, hit the bell, and stop paying corporate markups for chemistry that has been public knowledge for 200 years.